Right, welcome to our first lesson. What this is series about is basically exam questions. So in this series, I'm going to be doing mixed kind of questions that you'll expect in your exam. And for each topic, I'm trying to pick a bit difficult question. Okay. Now, question 5 says a chef is serving parsnips and carrots onto plates. There are 63 carrots and 91 parsnips to go around. Each plate must only have either carrots or parsnips, and there is no mixing of vegetables. Each plate must have the same number of vegetables on it, and each plate must have the greatest possible number of vegetables on it. Question A, find how many plates will contain carrots and how many plates will contain parsnips. I would like you to pause the video right now and try question 5. Right, so I hope you try this question. Now, what the question is telling us is this, that I have 63 carrots. And what I want to do, I want to put them into portions. I also have 91 parsnips, and I want to put them separately in different portions. Okay. Now, I'm going to put them in portions such a way that there's nothing that is left. So I'm going to be thinking about the numbers that can go into 63 here. So I could put them in portions of 1, portions of 3, portions of any number that would always go into 63. Portions of 21, and so on, because these numbers can go into 63. Likewise, for 91, I could put them in portions of 1, right? Portions of 11, any number that would always go into this. Okay. Right, so let's leave that for a minute. So we're being told that each plate must have the same number of vegetables in it. So if it's going to be the same number, then I'm going to think about putting carrots on the plates and putting parsnips on a different plate so that in each plate separately, they are equal number. So we are thinking about the number that can go into 63 and can also go into 91. Straight away, we are talking about highest common factor. We are talking about common factors. But we're going to be thinking about the biggest number possible because each place must have the greatest possible number of vegetables. So we are thinking about the biggest number that can go into 63 and can also go into 91. So highest common factor is what we're doing here. So forgetting about question A and question B for a minute, we want to find the H.C.F of 63 and 91. To do that, we're going to find the products of their prime factors, which we can do by doing the tree method. So we think about two numbers that we times together. So straight away, we're going to have 3. 3 goes into 6 twice, and 3 goes into 3 once. Now, this is a prime number. When it's a prime number, you need to circle it or underline it. This is not a prime number, so we carry on. 21, 3 goes into 21 7 times. This is a prime number, and that's a prime number. Okay. Then you do the same with 91. Now, with 91 here, it's quite difficult to know what number goes here. But what's going to happen is that it's going to be one of these numbers that's going to go there. So either 7 or 3, or either 7 or 3. I'm going to try 7. Right? 7 goes into 9 once, remainder 2, and 7 goes into 21 13 times. This is a prime number, and that's a prime number, and that's the end to that. Right, so to find the highest common factor using these numbers, what you need to do is this. You now need to lay them out using the numbers you had here, these prime factors here. So with the 63, I'm going to use 3 and 3 and 7, the ones that you've underlined. So it's 3 times by 3 and times by 7. Then with the 91 is going to be 7 times by 13. Now, to find the highest common factor, you're going to pick the numbers that are common here. What is common will be something you find at the bottom and also at the top. Now, this 3 is only at the top, so there's no partner that goes with it. This other one is only at the top. There's no partner down here that goes with it. However, this 7 can be matched up with this other 7. So we say that this 7 is basically common. So we can circle it and we just write it down. Okay? 13 doesn't have a partner up there. So the highest common factor here is going to be 7. So it means that these carrots, we're going to be dividing them into portions of 7 carrots each. Okay? And then the parsnips, we're going to be dividing them into portions of 7 as well. Right? So for question 1, it says, how many plates will contain carrots? Remember, one plate is having 7, but there are 63 of them, which means that I'm going to have what? I'm going to have 9 plates. Okay, so how many plates will contain carrots? There will be 9 plates, each with 7. And as for the parsnips, remember in each plate I've got 7. Now 7 times by 13. So 7 times by 13 will give you what? Will give you 91. So therefore they're going to be 13 plates, right? So that's how to do this question. So you might want to pause the video and just reflect on it again. So pause it and reflect on it. So the answer would be 9 and 13, just as explained like that. Okay. Right. So moving on to the next one, I would like you to pause the video and try this. The answer is 20 here as is shown, but I just want you to pause the video and try this. Okay, hope you've tried it. He says Kim is dividing counters into equal parts. She has 27 tangerines. Yeah, so 207 tangerines. And he also has 253 golden ones. Okay, so 253G. Each pile must contain only one of the colors. So these 207 tangerines must be put in portions separately, and this one must also be put in portions separately. Now, what is the least number of piles she can make it in total? Very quickly, I need to divide this into portions. I need to think about numbers that can go into this and numbers that can also go into this. But he's saying, what is the least number of piles she can make in total? For that to happen, I'm going to be thinking about the biggest number of tangerines that I can separate. So in each portion, how many tangerines will I have? And how many goals will I have in each separate portion? And it has to be the number has to be as big as possible. So we are thinking about the highest common factor, the biggest number that can go into this and can also go into this. So to do that straight away, you do the times table, the prime factor decomposition. So here again, I know that 3 goes here. How do I know that? Because you add the digits, and the answer should be in 3 times table. So 2 plus 0 plus 7 is 9, and 9 is in 3 times table. So this number 3 goes into it. Right, so 3 goes into 20 6 times, remainder 2, and 3 goes into 27 9 times. Okay, that's a prime number, you underline it. This is not a prime number, you break it. 3 can go here again, so 3 goes into 6 twice, and 3 goes into 9 how many times? 3 goes into 9 basically 3 times. Okay, that's a prime number and that's a prime number. So for 207, I'm done. So for 207, I'm going to do, it's going to be basically what? It's going to be 3 times by 3 times by 23. All right, so the prime numbers, the ones you've underlined, are the ones that you write down. Then as for 253, it's quite difficult to figure out what number goes here. But actually, 23 will go into this number. So if you have 23, if you times it by 11, it will give you 253. Okay, so as for 253, we're going to have 11 times by 23. Okay, so it's 11 times 23 is going to give us that. Now, what we're going to do now, we want to find the highest common factor. To find the highest common factor, you're going to pair up these numbers at the top and this one at the bottom and see which one is common. This 3 doesn't have a partner at the bottom, so it's not common. The other one doesn't, so it's not common. However, this 23 has a partner down here. So this 23 is the highest common factor now. Don't write it twice, just write it once. Okay? It means that these tangerines will be put into portions of 23 each, right? And these gold counters will also be put into portions of 23. But how many portions of 23 will I have here? So each portion will have 23. I will need to have how many portions? I'm going to need to have 9 portions because 23 times 9 will give me the answer. So the answer is 9 portions for tangerine. But how many for this one? Remember, one portion contains 23, and I will need 11 of that, right? So 23 times by 11. So I will have 11 portions there, and I will have 9 portions there, which altogether will become 20, right? Remember, it says, what is the least number of piles you can make in total? The least number of piles can only be made if you are using the greatest possible number that can go into both of them. The biggest number of tangerine we can have and the biggest number of gold counters we can have in both of them being the same number will be 23 and 23, right? So that then will make the least number of piles possible. Otherwise, we can use smaller numbers, right? We could use smaller numbers like 1, for example. but that's not going to give us so many, that's going to give us very, very many pies. Okay. Right, so that's going to be the end of this first session on reversing for GCSE.